Today's target will be exponent rules. This is the second exponent rules video. Make sure you've watched part 1. If you did not watch part 1 that covered multiplication, division, and power rules of exponents, you need to pause the video now and go back and watch part 1 before you continue on with this video. By the end of this video, by the end of today's lesson, you will be able to apply the properties of negative exponents and understand the zero power rule. Let's start off by looking at how exponents work. What we're going to look for here is a pattern. So we know at this point that 3 to the third power means that we're multiplying the base, in this case 3, by itself 3 times. So 3 times 3 times 3 gives us 27. 3 to the second power we know is multiplying by itself 2 times, which gives us 9. 3 to the first power means it's just 3. And if you look at our pattern here, every time the exponent decreases by 1, we're losing a 3. So with that, every time our exponent decreases by 1, our answer is being divided by 3. That continues from 27 to 9 and then 9 to 3. So using that pattern, if we look at 3 to the 0 power, 3 divided by 3 gives us 1. And the reason that is that we have something to the 0 power. We don't have any of that in the problem. So 3 to the 0 power means we have no 3's. We can't write 0 though because we need a placeholder, and our placeholder is 1. You can see by our pattern that it makes sense. Every time you decrease your exponent by 1, you divide by 3. So let's use that and go to 3 to the negative 1. So we continue our pattern. 1 divided by 3 gives us 1/3. So you can see that what the negative exponent does is it takes the base and it moves it to the denominator of the fraction. So 3 to the negative 1/3 takes that 3 and puts it in the denominator. Using that, if we move on and look at 3 to the negative 2, we would expect to see the base on the bottom. And now, because it's 3 to the negative 2, we have 2 of those. So 1/3 and 1/3. And if you multiply those together, you get 1/9. Now bear with me here, because if we look back at what we had in our second step, we know that that 9 is 3 to the second power. So 1 over 9 is the same as 1 over 3 squared. So if you look at what we have here, 3 to the negative 2 ends up as 1 over 3 to the second power. So what you have to remember with the negative exponents is that when you have a negative exponent, it turns it into a fraction, and it takes that base, whatever's being raised to a negative exponent, it takes that entire thing, moves it to the bottom, and the exponent becomes positive. The second thing we want to get from this pattern is the property of 0. So if you look at this line right in here, you can see that 3 to the 0 power is 1, and that's our 0 power rule. Oops, forgot an R there. 0 power rule. That rule says that anything raised to the power of 0 is equal to 1. So what that means is any number, any variable raised to the power of 0 is equal to 1. So once again, anything we pick, 5 to the power of 0 equals 1. 1,253 raised to the power of 0 is equal to 1. Any variable, x to the power of 0 is equal to 1. Let's say, for example, we had 3x to the power of 0. If we wanted to simplify that, since x to the power of 0 is just equal to 1, what we really have is 3 times 1, or just 3. So anytime you have something raised to the power of 0, you can basically just cross it off, because it means that we don't have any of that variable or that number. Let's take a look at how we apply our properties of negative exponents. Now we're going to do this using the multiplication, division, and power rules that we learned in the last video. So here we've got 4x to the negative 2 times 3x to the negative 7. We multiply these together just like what we did in the previous video. We're going to start with our coefficients. Now be careful, these exponents only apply to the variables. The two coefficients, 4 and 3, have no exponents. So we can go ahead and multiply them together. 4 and 3 gives us 12. Now we look at our variables. We've got x and x. One is raised to the negative 2nd power, one's raised to the negative 7th power. Our multiplication rule says that when we multiply like bases, we add the exponents. So we have negative 2, x to the negative 2 plus negative 7, which leaves us with 12 x to the negative 9th. Now, we are not allowed to leave a negative exponent in our answer. So what we do is we look at whatever variable or number is being raised to a negative exponent. And we take that and we put that in the denominator of our answer. So the 12 did not have an exponent, or more importantly, did not have a negative exponent. So it stays in the numerator, but the x to the negative 9th had to move to the bottom so that that exponent became positive. So our final answer here with positive exponents would be 12 over x to the 9th power. Let's look at an example with division. Okay? Same thing, I'm going to start with my coefficients. 15 divided by 3 gives me 5. Next, I'm going to look at my variables. I've got x and x to the negative 3 on top, x to the 5th on the bottom. When you're doing the division, you always subtract the top exponent minus the bottom exponent. So what we end up having here is x to the negative 3 minus 5, or x to the negative 8th power. And then with our y's, same thing, top minus bottom. So we have y to the 2 minus negative 7. Now remember, when you subtract a negative like we have here, we're going to end up adding a positive, so it becomes y to the 9th power. So there's our division rule. Dividing like bases, you subtract the exponents, top minus bottom. However, that left us with a negative exponent, x to the negative 8th. So when we write our answer, we would have 5 y to the 9th, because those two terms did not have negative exponents. And we move that x to the 8th onto the bottom, or the denominator, so that the exponent becomes positive. Okay? So that's the key. The key thing with negative exponents is to make sure that your answer has positive exponents. And the way we do that is we isolate any term, variable, or number that's being raised to a negative exponent and simply move that to the bottom, or to the denominator of our fraction. And in doing so, that answer becomes, that exponent becomes positive. So use what you just learned, use the examples we just went over, and you're going to try these two on your own. Give them your best shot. When you're done, press play, and the answers will pop up on the screen. You see here on the left, our final answer is 14 over x to the 7th, and that's because when we multiplied our x's together, we had a negative 5 and a negative 2 as our exponents. Adding them together gave us x to the negative 7th, and we went ahead and moved that term to the bottom to make that exponent positive. Keep in mind that the coefficients here, the 7 and the 2, don't apply to the exponent rules. We just multiply those guys together and get 14. In example number 2, 24 divided by 8 gave us 3. And then we're dividing, so we subtract our exponents. You always do top minus bottom. So we had x to the 4 minus negative 6. That became plus a positive and gave us x to the 10th power. Then we had y to the negative 5 minus 7. That subtraction gave us y to the negative 12th. When writing our final answer, that y had to move to the bottom because its exponent was negative. And in doing so, we can get rid of the negative. It just becomes 3x to the 10th power over y to the 12th. Make sure if you have any questions, comments, or concerns, you make a note of those. So when you come into class tomorrow, you can get those answered. We can do some practice.